Okay, hello, this is Stephen Marcus. This is a video on programming matrices in R. The reference that we're using is The Art of R Programming by Norman Matloff. For our purposes, this is chapter 4, but I think this is a draft that our class is using for this class, so it may not wind up being what chapter it was in the actual book, but we're doing matrices. A matrix is a two-dimensional array. Just to back up and review for just a second, let's take a look at a single dimensional array was a vertex. The way that you create a vertex is with the C operator, and then you list your elements for your array there. There we've created it. It shows up over here in my variables, and I can look at it by saying X. By the way, I'm using RStudio, which that's generally what you use for R. There's my vertex, and if I say class of X, it's a numeric. Okay, so if I can make another vertex, it shows up here as well, and those are characters. And I can look at it. And now if I want to reference those, the trick here is I'm actually using the same number more than once. Llama, 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 because I've got 1, 1, 1. So that's pretty straightforward. What happens when we use a negative index? It gives us everything except that. So if Y was llama, alpaca, ferret, tortoise, we dropped out alpaca because it was in the second position, and that makes sense. To use my numeric vertex, when we use operations, if I say X multiplied by 2, let's take a look at X by itself. It's gone through and it's multiplied every element by 2, and that's the trick with R. The things that we do are going to be on groups of data on arrays, and the operations are going to be on everything that we do. Vectors are single dimensional. Matrices are two-dimensional. So to make a matrix, it's sensible. You use the matrix command. So if I do this, it's going to create a matrix. My matrix is going to be called Y. I'm feeding it the matrix command, and what I'm feeding it is a vector that I'm creating on the fly right here, and my vector is just 9 digits. So if I create that, I have made a matrix, and if I take a look at it, it makes it's a column is what it is, but it's two-dimensional. It's one column of 9 elements. Let's create another one, see if we can make this make sense. Let's make, if we give it the number of rows that we want, this is going to be a matrix with 2 rows. That's the first time. It's hard to remember which window you're in sometimes. I'll do that again before it's over with, I'm sure. Here we go. Now I've made Y a matrix with 2 rows. So row 1, row 2. The thing to notice about this is that R is going to, by default, put things in columns first. So it's 1, 2, 3, 4, 5, 6. It's column wise. If we break this into, I'm going to put columns. You can put the number of row, number of columns. If you want to, you can put both, but you stand the chance of conflicting with yourself. Take a look at this. I'm going to have 3 columns. The problem is I've got 10 values, so that doesn't break into that evenly. So what happens when you make a matrix and don't have enough values? Well, R complains, but if you'll look at what it did, again, this is column wise, so it's given me a 4 by 3 matrix, and it's putting it column order first, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it starts recycling the numbers when it gets to the end. So to keep the thing from failing altogether, it just recycled the numbers. The column first approach to this is a little bit uncomfortable in my humble opinion. So what you can do is you can give it by row equals true, or capital T. And if we take a look at it again, it's got it in row first order. So that's how you actually build your matrix. Referencing. If we say y 2, 3, again, it's going to be column first. So it's going to be the second row, the third item on the row. So it should be 1, 2, 3 in the second one, and give me an 8. How about if I give it a comma and a 2? The comma basically resolves to everything in the first value. So for every row, give me the second column, which would be 2 and 7 in the order that they appear. So it's 2 and 7. That is saying give me the complete column of 2. If I give it just 2, it's going to assume that you want just the first value in that. What if I do the opposite, 2 comma? This means the second row, but since this value is empty, it's going to effectively mean all of the values. So that's going to give me basically just my second row and give me all the values in it. If I give it nothing but a comma, that's going to just say, okay, both of my values are open, so just give me everything. You can also specify a range. If we take a look at this, that is saying, okay, for the row, I want all of them. And for my columns, I want columns 2 through 4. So let's see if that actually makes sense. 2, 3, and 4, it should be, yep, 2, 3, 4, 7, 8, 9. So we have just a small subset right here by using the colon notation. Matrices are mutable. Yay! So if I do this and take 3, 2 and set it to a value, in this case 144, it didn't like it. Why did it not like it? There's your answer. There is no third column. Subscript out of bounds. So let's fix it. Give it something that makes sense. Second column, third item, it should stick at 1, 2, 3. Right there in place of that 8. And let's see if it did it. Yeah. So that allows us to change the values for things in the matrix. Operations. Let's take a look at this. Creating a matrix called Y. Easy enough. Here's my vector. It's got 12 items. It's got 3 columns. That should be a cute little matrix. No duplications. It's column wise. Okay, very simple. If I say Y times 2, it multiplies everything in the entire matrix by 2. So 8 becomes 16, 10 becomes 20. We can go through it and it makes sense. If I say 2 times, and then I'm going to reference something in my matrix. I'm trying not to say the matrix, so it sounds like I'm talking about the movie. This is what I'm doing right here. I'm multiplying 2 times my second row and all the values in that row. Let's see what we get. The second row of Y, here's Y, was 2, 6, 10, 4, 12, 20, makes sense. How about if I do simple addition? Y plus Y, it just does a, it wound up not doing anything, did it? No, yeah, it did. It did, I'm sorry. Here's the original Y. Let me put Y up there again so that it makes sense. 6 plus 6 would be 12, and 8 plus 8 would be 16. So it multiplied it by itself. So that's pretty straightforward. You can declare an empty matrix. In this case, it's handy to give it the number of rows and the number of columns because it can't just intuit it from what you're giving it. So let's take a look at it. It's a matrix of NAs, nothing there. So then what I can do is feed it some values. I'm giving it a range. I'm giving it rows 2 through 3 and columns 2 through 3 and give it those 4 values. Let's see what it looks like now. It filled in those 4 values. So that gave us a good way to we can reference that. We can do things like averages. Reset my matrix here. There's my simple matrix. If I do a mean and give it y, comma 1, what am I feeding it? I'm wanting all of the rows in column 1. So 1, 2, 3, 4. What would the average of that be? 2.5. That makes sense. The average of those 4 numbers is 2.5. And again, I'm getting all of the rows in the first column. This way of referencing is going to become important. How about if I do a mean of just y itself? That is effectively the average of the whole matrix. Row and column operations. Row sums, the sum of every row. 15, 18, 21, and 24. That makes sense. And similarly, you have column sums. A sum for every column. So those are really simple and straightforward to use. One thing that can be a little bit hard to deal with when you start working with bigger hunks of data, which is the main use for R, is making your data mean something. So it's if you're just having to work with column number 3 and row number 4, it can be a little confusing, hard to keep up with. Let's reset my matrix. There it is. If I ask what the row names are to begin with, I should get just an empty, yeah, there's nothing there. But I can set my row names for the vector, row names for the Y matrix. I'm just going to give it names. You have to type it in right, it turns out. There's my row names, and similarly, I gave it some silly column names there. But that gives it an easier way to reference these. And if I say, did it again. Oh no. I'm referencing Y by the red column. And since there's nothing here, it's going to give me all of my rows. It gave me 1, 2, 3, 4, and it just went down the way there. Lost my place up here. Here we go. And similarly, I'm calling for a complete row here with all columns. 3, 7, 11, that is line 3. So that makes sense. Okay, one neat thing about R, or R Studio specifically, is they give you some good reference material to work with. And there's one called MT Cars. And if you do a question mark, MT Cars, over here in the help, it gives you Motor Trend cars of 1974. This is, if you're geeky, this is kind of interesting just in itself. It's a small data set, 32 observations. Observations are rows, effectively, for 11 numeric variables. These are your columns and what they mean. So 32 rows and 11 columns. And it's just information about cars. If I get a class of what this is, what is it going to tell me? It tells me it's a data frame. Well, we're going to take a data frame, we're going to make a matrix out of it by doing this. I'm giving it a variable called MTC, and I'm just popping empty cars into it. There. And it's still calling it a data frame. Let's take a look at it. MTC, there's our information. You can actually, you may recognize this as just a Linux Unix command. You can use the head command, which is give me the first 6 rows. It's 10 rows in Linux, but it's 6 rows. It gives just a basic display of your information. Okay, here's where R really gets kind of fun, kind of interesting. If we want to reference some of this stuff and start doing stuff with it, we can reference it just like we've been doing. MTC, comma 1. So the empty set right here means I'm going to want all of the rows in the first column. My first column should be miles per gallon. You don't count this because these are the row names. So this is going to be my first one. Oops. Here we go. Let me get in the right pane. MTC column 1. It looks weird, but if you look, miles per gallon is 21, 21, 22, 21, 21, 21, 22, 21. This actually is it. It's just the data. It's giving it to you in just a one after another format instead of in a column. But that's our data that we asked for. That makes it easy to do stuff like getting an average. So the average miles per gallon in 1974 was, that's kind of low, 20.0. So that's what your car got to the gallon, or what this set of cars did. Average miles per gallon per cylinder. So if it's a 4-cylinder, let's see what we got here. This is, the actual answer is here. This is where it really starts to get kind of hairy, or it did in my opinion. That string of code, just, you kind of have to stop and look at it. The outside, I'm going to be pulling something from my data frame, from my matrix. What I'm giving it, I should be giving it 2 values. Well, right here, I'm starting off with an empty set, which means we're going to get all the rows of the second column that equal 4. So the second column is number of cylinders. So wherever the number of cylinders equals 4, so the first value that I'm putting in there is these. And the second one says give me all the columns. That's what I just put in. So these should be all the 4 cylinders. And there we go. We can do the same thing for 6s. And I'm going to do that just to show you that you're getting a different set of data, and that it's showing you, what we're wanting in this column. So what happens, right now we don't have anything set for the row. So let's do this, or the column is what that is. The second value is the column. Control C. So I'm pulling out if the second column, if the value in the second column equals 6, and I want just the first column, which is miles per gallon. Those are the miles per gallon of the 6 cylinders. So if we want an average of that, we can use the mean command. So for 6-cylinder cars, I pulled out the cylinder is 6, but the value I'm looking at is the miles per gallon. Don't feel bad if you have to rewind and look at this again. It's a little bit non-intuitive. The same sort of thing. Let's do horsepower greater than 200. So gross horsepower is the 4th column. And let's just take a look at it. This is breaking it down even further. So if I say, give me the 4th column, there's my 4th column. And if I say head MTC again, just to kind of get my bearings. Horsepower, yeah, 110, 93. This is what I'm dealing with, just that 4th column. So that's cool. If I want the 4th column where the value is greater than 200, what in the world is that? That's kind of like think of it as a template. It's returning all the values there. There should be 32 of these. And if you want to go to the trouble of counting them, you can. If it was greater than 200, you got a true. If it wasn't greater, then you got a false. Okay, so now I can use this to feed it to the reference to say which columns that I want or which rows that I want. There we go. Since I used, right here's the operative part of that. There's that comma, and then there's nothing after it which says give me all of the columns that I want. But notice the horsepower has to be over 200 in all of them, and they are, so that makes sense. Okay. So now we're going to use a function called nrow, or number of rows. That's the only thing that I'm adding here. So what that's going to do is tell me how many rows there are. 7. So if you count these, I'm going to guess that there's 7. The last thing that we're doing here is getting the row names of all the ones that are over 200. What that did was just basically give me the cars. That's as big of a bite as we want to chew off right now. Again, there's no shame in going back and rewinding some of this and working through what's going on. This gives us the basics of it. My intention is to work some more problems with these because they are a little bit funky. In my next video or two, I'm just going to take a handful of these problems and we're going to work through them with some practice information because this is some handy stuff. It's a good way to get information out of matrices. All right. Thank you very much.